The last clip involved a text problem. This clip also involves a text problem in which we're told that the distance it takes to stop a certain car is directly proportional to the square of the speed of the car. And we should know that this is how we write a direct proportionality to the square. We're given the information that when the speed is 70 miles an hour, the distance is 177 feet. So we immediately pop that information into the form of the proportionality, and we obtain this equation, which we easily solve for k. Obtaining k is 0.0361 feet over miles per hour squared. We take that value of k and put it back into the form of our proportionality, and we see that our proportionality is distance is 0.0361 feet per mile per hour squared multiplied by the square of the speed. Then, using function notation, the distance of 35 miles an hour, this is like an f of t or an f of x, distance of 35 miles per hour equals, I've got three dots here. We plug 35 miles per hour in for the speed here. We'll get miles per hour squared, which will divide this mile per hour squared, it'll go away. And we'll end up with a speed in, or a distance in feet. And we're going to end up with 44.25 feet when we do that. If we plug 140 miles an hour in for speed, we're going to get 708 feet. That's not actually how I go about calculating the distance. That's not how I calculated these in my head in class. I didn't really square 35 miles per hour and multiply it by 0.0361. I couldn't do that to that many decimal places, at least not quickly, and maybe not at all. What I did was I noted that 35 miles per hour was half of 70 miles per hour. Since we're squaring the speed, if I've got half the speed, I'm going to have half squared of the distance. Half squared is a fourth, so I just took a fourth of 177. I can manage that in my head 2 times out of 3, and I'll get 44.25 feet. Similarly, 140 is the double of 70. Since we're doubling this quantity and squaring it, we're going to end up with 4 times as much. 4 times 177 isn't that difficult to calculate, 708 feet. Symbolically, the way this works is as follows. We have a distance 2 equals k times speed 2 squared. And let's zoom in on that to make sure we can see it well. And a distance 1, which is k times the square of some speed 1, following the same relationship that we had over here. When we take the ratio of distance 2 over distance 1, we're going to have k times speed 2 squared over k times speed 1 squared. Well, the k's divide out. The speed 2 over speed 1 can all be grouped and squared. So we have the ratio of distances, distance 2 over distance 1, is the square of speed 2 over speed 1. The ratio of distances is the square of the speed ratio. So that over here, when we had a speed ratio of 1/2, we got 1/2 squared, or 1/4 the distance. When the ratio was 2, we got 2 squared, or 4 times the distance.